this last one is the last one we're going to do today, and we'll pick it up tomorrow. So here's another equation, y equals 5x squared minus 30x plus 31. Okay, so the difference between this problem and the previous one, the key difference here is the 5, right? The a value right here is 5, it's not 1. And that changes how you approach this problem. So to complete the square, using the process that you were given, you want that a value right here to be a 1 when you go into that process of cutting the linear term in half and squaring it, right? So in order to do that, we have to manipulate this. But before we do, the first thing you really should get involved in here is just moving that constant 31 away from the right side. So we're going to subtract it from both sides, and that'll leave us with this, right? Y minus 31 equals 5x squared minus 30x. Okay. But now we can't complete the square until that a value is 1, all right? So you do not want to divide it, all right? You'll see some people divide it, and they can work through the problem that way. It's just far easier to not divide it because there are going to be cases where you're not dealing with an equation, but you need to complete the square, and you can't just divide it away. So an alternative to dividing is factoring, right? So what I want to do is I'm going to factor the 5 out of the variable terms here, right? Quadratic and linear term, just the 5. You do not want to factor the greatest common factor. So I don't want to factor 5x, I want to factor 5. So when I factor 5 out, I'm going to factor 5 out of x squared, I'm left with x squared. I factor 5 out of negative 30, I'm left with negative 6x, right? That's where we're at. So everything in black right now is where we're at, right, with the factors. Now we get into completing the square, okay? On the right side of the equation in the black group, right? So I have an x squared, I have a negative 6x. The b value right now is negative 6, so I'm going to use that to complete the square. So I'm going to take half of negative 6 right here, and then I'm going to square it. So that's technically a value of 9. Right? So I have it, and then, right, remember, whatever you do to one side of the equation, you do the other, so I'm going to do that over here. Half of negative 6 squared, that's 9. I added it to both sides, okay? So, at this stage, a mistake occurred, all right? And you got to be careful with this, because it happens. Whatever you add to one side of the equation, you add to the other side. I'm going to modify that and say, whatever value you add to the right side of the equation, you add to the left side of the equation. So written down, I'm adding let's see, let me show it here. I'm really adding a 9, right? But this equation on the right, this black group right here, is technically being multiplied by 5. So even though I wrote plus 9 in the group, that's really a value of plus 45. Okay, and I need to address that when I deal with it over here. So if you just write plus 9 on the left side, you're not actually balancing the equation. You're only adding 9. But the total value we added was 9 times 5, which is a total value of 45. And that's the part that's different about this problem that you have to kind of not ignore. You added 45 to both sides, and then we clean it up, right? So we have y minus 31 plus 45, so what's 14, y plus 14 equals 5, and then again, x squared minus 6x plus 9, okay? I need to factor the right side. So again, most of you are not going to write the factors out as I'm doing right now, but you're looking for two numbers that multiply to 9 and add to negative 6. That's negative 3 and negative 3. If you actually completed the square correctly, these two values I just listed are always going to be the same. So it's going to be x minus 3, x minus 3. But most of you are going to go straight to x minus 3 squared. That was the whole point of doing what we did. Don't forget about the 5, and don't forget about the y plus 14. This is now in vertex form. And from here we can identify the vertex. Vertex is the point positive 3, negative 14. The a value is positive 5, so it's going to open up. And And the fact that 5 is larger than 1, right? The last graph we looked at had an A value of 1. This value is going to be stretched vertically upward. So it's going to appear more narrow than the standard graph. So if this is the standard quadratic function, then the one we're going to graph tomorrow is going to be much skinnier, right? Much narrower. And it's not because the 5 isn't necessarily pushing the curve in closer to the line of symmetry. It's actually stretching all the values upwards, right? That's what that 5 does. So if this is a point on the red curve, the 5 is going to stretch it up to this point. Same with this, right? It's not pushing it inside, it's stretching it up vertically. It just appears that it's getting pushed in that way. And that's all we did today, so we'll leave it at that. You can attempt to do some of the assignments, and then we'll pick the rest of the lesson up on Friday.